Hello students, in this video, let us learn about Isaac Newton and the concept of the deterministic universe proposed by Sir Isaac Newton. So as you all know, Isaac Newton lived in the 17th and the 18th century from 1642 up to 1727, and he laid the foundation for mechanics, fluid dynamics, optics and calculus. So he was a great scientist who had contributed to a variety of fields. In whatever field that you study in your basic classes, you may find some of the contributions from Isaac Newton. He did not work independently. Actually, he built the works based on the works of others like Galileo, Kepler, etc. Especially you can see that the observations made by Galileo, Kepler and other scientists were used by Isaac Newton in formulating his own theories. And his famous book, The Mathematical Principles of Natural Philosophy, often called as Principia Mathematica, and this book formed the basis of much of the classical physics, the classical mechanics that you study. Now let us discuss about the Newtonian conception of universe, the idea how Newton tried to explain the concept and working of universe. So according to Newton, the universe consists of infinitesimal material points commonly referred to as particles. So in terms of the motion and working of these particles, the working of the universe was explained. Extended objects are treated as assemblages of particles, and the behaviors of objects are determined by the behaviors of the particles of which they are composed. So for example, in the case of Earth or a bigger body, this Earth is composed of small minute particles. Motion of each of the particles can be analyzed to get the big picture. So you might have seen this kind of treatment in the physics of many body particles. And the properties of the particles include mass, electric charge, position, etc. So if we analyze the properties of the particles, and if you are able to explain how this would work, how these properties would change over time, then according to Newton, you can determine the evolution of the universe. So this is the concept that we will be trying to explain. The characteristics of the Newtonian concept are, it is complete and it is deterministic. It is complete in the sense that if you are able to list out what are the particles that existed and their various intrinsic properties such as mass, charge and other properties, and what are the positions of these particles there, and this list will represent absolutely everything that could be said about the physical history of the universe. It could contain everything that existed and every event that occurred. So this is the concept of completeness according to Newtonian concept. So as we know, there are many number of particles in the universe, and if you are able to describe the properties, the intrinsic properties of all these particles, then that would actually contain the history and evolution of all the particles. So in a sense, at one point of time, if you are able to denote these properties, and we are also able to describe the basic equations that evolve these properties, that change these properties, then a complete picture of the universe can be understood. So this is one of the main characteristic of Newtonian concept. Say for example, if you drop a ball from an aeroplane, suppose this ball is in the air at time t equal to 0. Then if you know the gravitational force G, which is 9.8 meter per second square, and if you also know at what initial velocity this ball was launched, then you will also be able to find its initial or other velocities at different time, or its past history will be able to be predicted. So in a similar manner, the history of all the particles in the universe can be predicted, and if we list out all the properties, position, mass and other properties are listed out, and its evolution are determined according to certain equations, then that could actually describe the complete picture of the universe. So that is the concept of completeness. Then the second property of this Newtonian concept is its determinism, or it is deterministic. This simply implies that everything can be determined if we are given with certain parameters. So if we are given with these intrinsic properties of the particles and the equations, the basic dynamics of these particles, then the entire future history of the universe can be predicted. So according to completeness, the past history can be completely obtained from certain parameters, and according to determinism, the future can be predicted. So these are the two characteristics of the Newtonian concept. We will look into this property of determinism, according to which all the properties, all the future of the universe can be predicted in this class. So as indicated in this picture, if you are given with certain parameters like the initial cause, then the variables that are involved in the dynamics, then we will be able to get the final effect from these minimum set of given values. So for example, if you are given with the initial velocity u, which is 2 meters per second, then if you are given with the acceleration acting on this particle, then you can automatically predict the final velocity v at time t. Similarly, there are other sets of equations that will give you the displacement or the momentum, final momentum, and so on. So according to this deterministic principle, thus if you are given with the cause and the set of variables that describe the system, the final effect can be completely and accurately predicted. 100% is predictable. So this is what the principle of determinism is about, not just in the field of this Newtonian mechanics, but also in other fields such as the gravitation or other fields in thermodynamics or optics. This determinism holds. So according to this principle, according to the laws of motion, his laws of motion along with his theory of gravity formed a solid basis on which celestial motions with all its complexity could be explained. So you have studied about 3 laws of motion, and you might have also heard about Newton's law of gravity. And if these laws are used together by Newton, if these laws are used, then the working of the celestial motion can be completely explained according to the Newton's theory. And his theories led to a picture of the universe that works with the precision of a grand clock. Say for example, with the Newton's theory, if you are given with the current position of Earth right now, you know gravitational force is the force acting between Sun and Earth. And according to this Newton's theory, you will be able to predict the position of Earth after some time, 6 months later, and so on. Similarly, the motion of all the planets and celestial objects can be predicted based on the Newton's theories. So this is what is called determinism, because if you are given with minimum set of parameters, the position, momentum, and the forces acting, then everything can be determined. And according to the Newton's theories, if we know the force acting on a body, we can calculate the acceleration from Newton's second law. What is Newton's second law? F is equal to dp by dt, or F equal to ma. So if you have the force acting on a system, then you can predict the acceleration, and from the acceleration we can find the velocity and displacement by integration. So acceleration is dv by dt, right? And it is d square x by dt square. X is the displacement. So if you have the value of acceleration, you can automatically find velocity, and you can also find displacement by just integration. So if you are given with acceleration and force alone, other physical features and the evolution, the displacement, in the future can be predicted. So this is the concept of determinism. So maybe you have solved many problems in your classes where you are given with the initial position, then you are given with the forces acting and the height, and you are asked to find several other parameters, the time in which this ball will reach the ground, or the path which this ball will choose, and so on. So these treatments were completely based on the concept of determinism, where we assume that everything is determined based on these sets of equations. You might have seen plenty of problems from Newtonian mechanics where you dealt with different particles, different types of motion, the motion of cars, trains, etc. were analyzed, and you were able to predict where will this car be or this train be at time t, or time t equal to 10 seconds, or after some time, or what its velocity will be after some time, so and so. So this determinism was the basic concept that you used in this kind of problem solving. Now to summarize, in the classical Newtonian mechanics, the main feature that we see is determinism, and according to this, universe has a starting point which can be taken as Big Bang, and correct formulations for laws of nature allow histories of all particles to be traced and predicted into the future. So according to this determinism, everything is predictable and universe functions like clockwork with accurate precision. So in this concept, there is no place for free will, and the deterministic universe just works like a machine where everything is earlier predicted. Now in the later centuries, when science further evolved, this theory of scientific determinism faced a lot of challenges. Now it is not considered that everything is predictable and determined. For example, in the field of quantum mechanics, we have a lot of concepts relating to probability, and nothing is accurately predicted. So this challenged the scientific determinism. Maybe you are aware about the Heisenberg's uncertainty principle. Delta x into delta p is greater than or equal to h cut or h cut by 2 pi. So this itself implies such uncertainty, right? So when we come into quantum mechanics, we have several laws like this, which is against the concept of scientific determinism. Everything cannot be determined accurately. Now in the case of other fields like nonlinear dynamics and chaos, these kinds of conventional models and determinism are being questioned. So as of now, in that century when Newton developed these fields, many of the systems in the universe as well as many of the physical systems were able to be analyzed using these deterministic principles. So to some extent, these principles were very good and based on strong physical principles, but to some other extent, these concepts made a negative impact in the sense that it brought a concept that everything can be determined. But in fact, everything cannot be determined. Or is it possible to determine the future of the universe just based on certain set of equations? So that's a question that holds now. So as of now, this concept is clear. I hope this concept is clear for you. Thank you.